Okay, so what is a ROSject? Okay, so a ROSject is just a ROS project on the cloud and whose files are organized in the following way. So let me open here. First, any simulation related to that ROS project is going to be put into this simulation workspace. Then any ROS code, the code that will run into the robot, has to be put inside here, the Catkin workspace. Finally, any documentation, tutorials, or lessons that are related to that code simulation, to that project, it has to be put inside the notebook workspace in Jupyter notebook format. So what to use this for? Well, you can use a ROSject to share and reproducible robotics results. You can share very simply by using a link. We are going to see that in a few minutes. So, for example, by creating a ROSject and then sharing it, you can ensure that whoever who opens this ROSject, the project will work, because the ROSjects are executed here on the cloud, so they do not depend on the configuration of the computer of the receptor. ROSjects are like Dockers on asteroids because they work off the shelf without requiring any installation, any configuration on any type of computer without modifying a single comma. ROSjects are executed here in the ROS Development Studio, that it's a cloud platform. But also remember that you can, at any point in time, you can come here and download the whole project to your own computer and then execute it in your local machine, provided that you have the proper configuration. Okay, so let's see now how to create a ROSject and how to share it. So for that, I'm going to close this and let's go here. So let's create a new ROSject on the ROS Development Studio. You create one here and then you say my ROSject, for example, and it's private and description, this is my first project. Then create. You can assign an image also by editing here. So now that we have created this ROSject, let's open it. Once we have the project open, I'm not going to restore my previous, then we only have to do is to fill it with the proper information. So let's create the same project that I showed you before. And the first thing is to go to the IDE. Then what do we have to put here? The simulation workspace that is empty, so it contains nothing. Here we have to put the simulation that we want to run for this project. So let's imagine in this case that the simulation is on a Git. So it's here. For example, this is the simulation that we are going to use for that example. So let's go and then clone it, that simulation here on that workspace. For that, let's go to the shell and let's go to the simulation workspace source and do a git clone of this address. And now it's cloning and it's putting the Git information here on the simulation workspace. That is very interesting that we generate our simulation from a Git, because that means that the package installed here, it's Git synchronized. So any change that you do to the simulation in the future, you can push it to the simulation or do your pull request in the same way, or any other simulation, any other change that is done to the simulation in the future, you can just recover here in the ROSject without doing anything else, just pulling it. Okay, so it's taking some time to get the whole amount of data, but it's getting there. Okay, we got everything. Then now we have the simulation there. The next thing that we have to do is to include the code of ROS that is going to be executed on that simulation. So this simulation is the simulation of a turtlebot on a maze that we have done for an OpenAI example. And the code is going to be included into the Catkin workspace. So here we go to the source, and then in this case we are not going to clone from a Git, but instead we are going to take it from another directory that where we have this information. So let me So in this case, we are going to take this information from my hard disk. So those are packages of ROS that I have created in my local computer, and I want to upload here to the ROSject, for example. So I'm coming here, and here I have inside the source, I have the packages that I want. That's very easy how to do it. So let me just show you. I'm going to come here to the source and then select the option of upload information that is here on the file, upload local files. Then I'm going to grab the ROS packages. Those are my ROS packages. Just grab them and upload them, and that it is. So it's uploading everything, and great. So we have here my turtlebot package, my OpenAI ROS system, etc. So everything, I have it from my local computer, and that's it. Final thing is to include the notebook. So the notebook, we include by default one default notebook that is empty and some images, but I'm going to delete this just to prevent conflict with the one that I'm going to upload. And here on my ROSject, here notebook, I have my own notebook also. So let's do the same procedure. Upload local files, select this and upload there. And that's it. So now we have the simulation here that I have downloaded from the Git, the notebook that I have uploaded from my local computer, and the ROS code that I have uploaded here. So how do I use all that? Well, very easy. So first, let's launch the simulation. You should compile that. And now I know that it is not required for that simulation, but in another case, just go to the Catkin workspace of the simulation. So here, and then you do a Catkin make. Okay, so far so good. So it's going to compile, no problem, because there is no compilation. How to launch the simulation from here? Go to the simulations, select launch file, and then select the package that you have uploaded. And those are the launch files contained on that package. Let's select main launch. So now the simulation is going to be launched here. Also, in order, at the same time, let's open the notebook that we have uploaded. So the notebook is here. But in order to open it, it's in Jupyter Notebook format. So we need to come here and open Jupyter Notebook. And here we have our notebook. Let's open it. And we'll see all the information that we have included about OpenAI, and ROS, robots, etc., demos, etc. That is related to that maze and to that is code. So you can see it includes many information that you can provide to your students, to your research lab mates, whatever. And this image should appear better, but I don't know. And here so that's a notebook, okay? And finally, you can run the code. So the code is on the Catkin workspace. So you can go to the Catkin workspace and the source, and there you have to compile also in this case. So you compile, and then execute. Remember to source also whenever you have compiled, to source it in order to get the latest results. So basically, that's a way that you create a ROSject. Once you have that, you can save at any time by pressing this button here and save your changes. So I'm going to save to my ROSject, of course, and overwrite whatever is there. So now my ROSject contains the simulation, the notebook, and the code. So in case that you don't have any simulation on the cloud or on a Git, you don't have any code in your local computer, you don't have to worry. You can start creating this from scratch here. You can create your packages, use like a normal local development environment, but this time is on the cloud. So you can open all the files and see controllers connection in Python or C++. So that's it, compiled, and then in order to execute, actually I don't remember the instructions, but we can check it here very quickly. And this images should appear, let's see, yeah. And here also, yes, and also here. Yeah, so we changed the simulation environment a little bit, the format, so you can see here on the simulation that it has been changed, but it's basically the same problem that we are trying to solve here. Yeah, okay, so yeah, so you have to create some packages and put the code and try it, etc., etc. A lot of work. So basically that's it. So we have our project done. Then now imagine that now it's working, so you can open this notebook, you can open the simulation, you can execute the code. Then how are you going to share this with anybody else so that anybody can start from this point? Not by downloading, it's by something that is running already. Well, it's very simple. Just go here to your ROSjects that you have done. So yeah, leave. And here I have my ROSject that I have just created. Then you press this button and then select the link, the type of link. So you have a permanent link. This is a link that you should use to share this in your website or something. So this link is never going to finish. So it's going to be valid forever. In other cases, you may need just a temporary link. When you go to a conference, I just want to share this with some specific people there, not forever. So that's a temporary link. Then if you open this and you create, so you copy this link. So what I'm going to do is to open a different browser, and I'm going to paste the link of the ROSject here and then press here. So this automatically directs me to this page that explains about my project. This is just first is an example, so you can put here a better description and another image. And here let me use my username here in order to get into this example and logged in into the system. Then automatically the ROSject has been copied into my other user. It's a different user and it's being copied, and I can now launch it in the same way as the other ROSject that we have here. So this is the original one that I have created with my usual account, and then here with a fake account I have received the same ROSject, and I can open it and I will get the exact same information. So if this original one was working, as we saw that it was, then in this one, in the second one, we can see with a different user, we can see that the Jupyter notebook is here. We can open and get all the information that the simulation is here, and we can launch it, and that the rest of the code is also here on the Catkin workspace. all my packages and working. So basically that's it about the ROSject. I hope that you found this interesting, because maybe you are thinking, okay, that's very interesting, but what can I use ROSject for? Well, you can use it to provide lessons, for example, to your students, or to reproduce your research results by other people. So you are presenting to a conference your results, and then you want somebody else to reproduce it. Just share the ROSject where you did your development for the paper. Or you want to share your work and let somebody else continue from the exact point that you left. So that's the power of the ROSject. And in the future, we'll provide more information about how to use ROSject in a more effective way and how to increase your professionality while creating programs for ROS-based robots. So thank you very much. That's all.